Thank you, Karasov, for having us back. We're here today to take a look at a new feature set on the Google Maps platform. So for those of you who are familiar with AppGeo, we are now a wholly owned subsidiary of Sanborn Mapping Company, and we're now leveraging all of the capabilities of this larger combined organization. This new company brings our customers more data collection capabilities than ever before, coupled with AppGeo's technical consulting. Sanborn is also a Google Maps partner, along with AppGeo, who's been a Google Maps partner for many years now. So together we bring lots of combined experience to the table, including on Google Cloud and Google Earth Engine, which is something we've been excitedly getting into as well. So what will we be looking at today? We're going to walk through this new data-driven styling feature set and some of the capabilities within. We're going to show you some examples and demos that we've prepared to give you a live look at what you can create using these features. Also, some of our tips for working with statistical data and creating maps using this tool. And then lastly, some advice we have on how you can get started and where we could help you implement some of these for your own organization. So let's take a look at this exciting new feature in Google Maps called data-driven styling. This is a feature that was launched to the public really only a month or two ago. AppGeo was invited to be one of the early testers when it was in alpha, and we had a good amount of experience getting in and providing some feedback that led to the final product. So we feel really confident that this should be a good opportunity to share all of our learnings with you today. So what is data-driven styling? Data-driven styling, or DDS, as you might see it referred to in some of the materials, is a new capability to enable creating thematic maps for visualization and analytic purposes. It takes advantage of Google's administrative boundaries, such as states, counties, metropolitan areas, and even zip codes, and enables you to do thematic styling generated using tabular data from outside Google sources, such as your own data or third-party data, like census information, for example. Now, Google is introducing a new concept with this capability of bringing your own data or third-party data and combining it with all of their existing base map data, which is such a well-known feature of Google Maps as it is now. And we believe this really opens the door for many more let's say, traditional GIS users to take advantage of mapping technology and creating maps using the platform to not only set these up, but also to interact with and visually engage with these maps in all sorts of new ways. So let's talk about that in a little more detail. So you may not be aware the extent of the polygon data that Google Maps already has under the surface. If you were to type in your town, for example, you might get a red outline like you see there. That's actually tapping into a data set that has always been within Google Maps platform, but hasn't actually been accessible to the user until now for styling purposes. So you can see a couple examples here on the screen of those geographic units being selected. Google has multiple levels of these boundaries available. They're all start as polygons, and they go all the way from the country level down to states, counties, zip codes, and even individual towns. And in some cases, these are going to have overlap and things like that, depending on how they're broken up. But in general, there is complete coverage for the US for this feature. And in the US, which is, I believe, our audience that we're speaking to today, there are 7 total boundary types available to you, giving you a lot of flexibility in how you might want to implement this tool. You can find which regions are available in your area, which polygons you might want to start using by checking out this region coverage viewer. In here, you can type in anywhere in the US and, for example, check out what the zip code boundaries or the neighborhood boundaries or the county boundaries look like to get a sense for if the data that you're trying to map out is appropriately covered. But from everything we've seen, the coverage is really great. The concept behind this feature is pretty straightforward, and that is we're looking to combine your tabular data related to these administrative boundaries with Google's existing boundary data to create a map-based visualization. For those of you on the call who have GIS backgrounds, this probably seems really straightforward, but the real benefit of this tool set is it opens up those capabilities, we believe, to a far wider audience. Now we have what we like to think is a great state and local as well as different government agencies on our call today. So we're going to be focusing on some of the use cases that are most applicable to your users. And some of those might be socioeconomic data, broadband access, access to social services. There are many types of data beyond just demographics that we can potentially map. And this really opens the door to those possibilities. So here's a simple example that could be relevant for understanding property growth trends around metro areas. You could bring in property values such as recent sales or assessments and appraisals and calculate some basic statistics like the minimum and the maximum and the average or standard deviation for a given zip code. And then you can generate a map showing those property value statistics by zip code or even at the neighborhood level to understand changes over time or changes in values and identify potential outliers and target different assessment strategies based on that. This particular use case would be relevant for both users in the assessment and appraisal world, as well as the public to understand property values throughout a city. Of course, it can go much deeper than that, and we came up with a handful of ideas, such as showing population type maps or resident density, household income, all of those type of numerics. We could also use this for, and this was particularly relevant for over the past couple of years, mapping things like vaccination rates or case counts for different diseases if need be. We could also generate maps showing hospital stays by area and the available capacity, for example. And we could also use this to look at potentially school districts or even to assess districts compared to each other with attendance or testing scores. There are many possibilities. So we wanted to open your imagination to that today, as this is a tool that we hope is going to get widely used across all departments. So let's take a look at some actual thematics that we are generated using this data-driven styling feature. These are some examples that I created using the tool. And to give a disclaimer, I'm not a professional programmer. I'm a professional AppGeoer. And I was able to put these together with a fairly basic knowledge of the APIs and the code required. So that will give you a sense of the difficulty in taking it on yourself. So in this case, we're looking at a map that is just showing population by zip code, the easily accessible data. And this is being generated in Google Maps by feeding it, those zip code numbers and a population count for each one. And it's going to spit out a map that looks like this. And down the road, I'm going to go into these in a live demo, as well as talk about some approaches for binning the data as we need to come up with a rationale behind the color for each one of these polygons. So in this second example, we've combined that population data set with another value, and that is the area of the unit. In this case, we can create a map showing residents per square mile, which is going to give you a better sense of the density of the urban area. And this is another one that we're going to look at in a live demo setting. This third example shows average income per zip code coming from census data along with population data to show the average income within a particular zip code. And this is something that you could use to understand economic development, either at the state level or metro area level or county level, all being done within Google Maps. So again, we have quite a bit of flexibility when it comes to what we're showing and how we're showing it. So hopefully with these few examples, you have gotten an idea of the power of this new capability. And for the first time, in our opinion, Google Maps can really be used as a geospatial analysis tool with any type of external data that fits into this, this type of display combined with their boundaries. And this really opens the door to a lot more users taking advantage of this capability, especially with, I think, what we could consider a set it and forget it type approach, where we've created the map and are feeding it a data set that updates over time without having to do any GIS processing in between. So from here, I want to walk you all through exactly what you would need to do to get started with this feature, as well as show off those demos, which I had a lot of fun making over the past couple weeks. So for those of you who are already a little bit familiar with the Google Maps platform, this is a function that exists within the console, and it's something that you can enable for any given map style. And I believe we previously did a webinar talking about this custom styling, a lot of exciting stuff in there. And I would like to think about this feature as an extension of that in some ways. So when you go into a customized style you've created, you can see down here in that yellow box, data-driven styling, and there's a drop-down. Opening up that drop-down, you'd have the ability to select which geographic units you'd like to have available to you for analysis. So you're going to need to turn those on for each given map that you're creating. One last little note I'll make is this is a very important point when getting started. As Google Maps now supports vector-based mapping, this is a feature that requires that vector-based mapping to be turned on for your particular use. So make sure that the map that you're working with, you've chosen that JavaScript vector option. Going on now, we've set up our map in the console, and now we need to bring in some data. So with any time we're creating a map with these choropleth styling, which is those multiple colors, we have to decide a method to determine, what color is going to go with what range of values. And this process is known as data binning. Again, for many of you on this call, you've probably studied this at a great deal, but the real basics of it are this is just grouping our data into different bins in order to, assign them a color, in this case, to visualize. There's a few different ways to do this process, and the best method is really going to depend on the data set that you're working with and its characteristics. Some things to consider when choosing a method include the number of data points you have, the range of values, and even the desired level of detail. Whether you have 3 or 4 colors or 22, it makes a difference in legibility. And you might, for example, want to consider setting your midpoint around the average of the data set to give users a sense of the trend, whether a particular area is above or below that average. But again, very specific to the problem at hand. And this goes into one of the tips that we're bringing you today, and that's about choosing an appropriate geographic unit. How do I know if I want to use counties or towns or zip codes? And answering that question is based on what the question you're trying to answer with your map. What do you want your users to be able to understand? If we're talking about data that rolls up to make decisions at a county level, it might make sense to summarize at that county level and show, that kind of data. If we're talking about something that is more geographically focused, like, where do we need more school bus stops or libraries even, that's something where having that zip code level of accuracy opens up a bit more specifics around, where that population actually is. And, because of the uneven nature of the distribution of human populations, no single geographic unit can, perfectly capture the data. So we're, as geographers, always making decisions about, what choices to do there, and taking into things like scale and purpose as we go. Another tip is to consider when to apply normalization to your data. For example, if we're creating a map trying to show vaccine rates, rather than just showing the total number of people who got that vaccine, we might want to show the number per 1,000 or divide it by the total population for that area. Because, for example, we might have some areas with a smaller population, and simply showing a count might not give us a good representation of what we're trying to show off, which is, in this case, what % of that population meets that criteria. So there's obviously a number of different ways to perform this type of normalization, but typically you're going to be dividing either by the number of people who are living in that area, or potentially by the area of that unit for certain applications. And our last tip in this section for today is about choosing a binning method. I thought this was an interesting example here. You can see 9 different maps, which are actually all showing identical data, but the way in which they have been divided is 9 different methods. And the method you choose here should be appropriate for the data type being mapped. For example, for quantitative methods, something like equal interval or quantile might make more sense. But again, this is an area you could have a whole college course in, and we don't have time to go into all of it on our webinar today. But again, it's something to consider when working with this type of data and creating maps. So from here, I want to dive right into our demos to make sure we have time to cover them all. We have 3 to show you today, and the first one is that population map from the beginning of our presentations. So we're starting with the Google map that all of you may be familiar with, and this has on the fly from the data I added to the map, generated this population map, in this case in Massachusetts where I live. And just like with any Google map, you can zoom in, out. If we were to click on an area, we could customize what is shown in that pop-up. And we can even dive right into things like Street View, which your users might be able to take advantage of depending on what it is you're trying to show off. And again, it's fairly straightforward, but the ability to have these polygons, you can customize, of course, all of these colors, all of the transparency options and things like that, and really create something that is unique to your use case. Now, moving on to the second demo here. This is a similar map. In this case, we're showing the population density, residents per square mile. And just to give you a sense of the power of this tool, in this case, I've gone beyond mapping just Massachusetts and loaded in about 10,000 zip codes from all across the East Coast. And as you can see, the performance is quite good. I'm able to load all of these up. It's all in the browser with nothing downloaded locally. And we can zoom in and get a sense of population density. There are a couple additional features like being able to tilt and pan the map. We could add a search bar just like any other Google map, and even quickly switch over to satellite view. It's not going to have the overlays, but you can kind of use it as a way to verify your data. And yes, indeed, Upper Manhattan and the Bronx is quite populated, as the dark red, purple here would imply. So again, really powerful, really fast, great performance. And all of this is running from really a few lines of code. Now, the last demo I want to show with you today is a type of map many of you may have seen published by different states throughout the last couple of years. In this case, I took some sample vaccination data. Again, this is just sample data. Here we are able to take the percent of fully vaccinated individuals per zip code and create a quick map. And this is an example of a map that might be changing again on a daily or weekly basis. And the colors that I've chosen here might be used to, for example, we might have a target of 70% that our Department of Health is looking to hit. And it's a really easy way to see, all right, where are the communities that we might need a little more help, and where are the ones where we're doing really well. Another area here that kind of goes back to what we were speaking to about our data and outliers is you'll see these red ones might imply that they're super low, but it's a good lesson in checking out your data, as this particular area is an area where nobody lives. So a population, a full year-round population of 0. Same goes for some of these areas here. This is actually a state park out in Western Massachusetts that, for whatever reason, has its own zip code, and as a result, no one there to get vaccinated. So creating a map like this is always a great way to gut check your assumptions with your data, and also really clearly identify any outliers that you might want to tidy up before it goes to the public. But hopefully this gave you a sense of some of the different ways you can implement these features. Again, especially when you open it up to like towns and counties, your imagination is the limit in terms of what you can do with this. And we'd really like to see what folks can come up with. One last little feature I forgot to show off before, but if we zoom in, we can see that I've stylized this map to have, for example, the medical centers shown on top of the data layer that we're coloring in. And you could do this with your own locations as well. So for example, we could have this map overlaid with all vaccination sites in the state, and from that maybe make some assumptions about, all right, we need more in this town, and things like that. So again, a lot of really powerful features that can be helpful for decision making at many different levels. And there are tons more that we won't have time to go into today. So I just want to wrap up really briefly with how AppGeo can help get you started with these new features. And we're no stranger to helping our clients and organizations across the country take full advantage of Google Maps platform. And that's why we created the Spatial IQ Consulting program. This is something that provides access for your development teams to our experts to get the best advice pertaining to implementing the platform, choosing the APIs, optimizing your usage. Of course, these APIs are very flexible and can accomplish a lot. So oftentimes the most difficult part of the process is really just understanding, that application architecture. And that's something that we have quite a bit of experience in. We can assist you with setting up data-driven styling and offer advice on preparing your tabular data to achieve, the relevant thematics, making really effective maps. It's something that AppGeo has done throughout their 30-year history, and something that Sanborn has done for their almost 200-year history, I believe. So you got a lot of smart map people that are excited to help you out. And the Spatial IQ program is especially well suited for those who have new Google Map projects they want to get off the ground, and perhaps development teams that are not familiar with this technology but are technically inclined in general. And we've assisted many clients that are looking to spin up similar applications, like the Pennsylvania Department of Human Services, who had a great team and just wanted to get smarter with Google Maps, and they were able to achieve that with their vaccine locator. Now, in the case that you don't have internal resources to take on one of these mapping application build-outs yourself, we can assist. We have many years of experience developing and hosting geospatial applications that go from the very simple to the very complex. We also have a strong background in creating geospatial strategic plans to lay out roadmaps and processes for achieving your organizational goals at all levels involving geospatial data. So if you have a bigger picture problem that you're looking to solve, we are here to help, and we provide a full suite of professional services on top of everything we talked about today that'll help take on any challenge, be it in Google Maps or otherwise. Now, I do want to encourage all of you to submit questions. We have a few minutes to get through all of those. And while those are coming in, I just want to mention that we are on YouTube as the Mapping Channel. We have several Google Maps webinars we've done in the past, which have some great information ranging from billing and pricing all the way to, for example, configuring those custom styling. And of course, this recording will end up there as well. So I encourage you to check out the Mapping Channel if you found today's content interesting and are looking to learn more. So from there, I'd like to take it to the Q&A where Dave has rested his voice and can join us. But in the meantime, I think we are ready to field some questions. And again, thank you all for being here.
Yeah, so feel free to send in some questions in the chat. And it seems that we already have a few. I'm not sure if this one was already answered in those last slides, but the first one is, can we filter out / stylize Google's own POIs on the map?
Yes. So you can go into a great level of customization with the new Google Cloud styling features, which they rolled out, I think it was about a year ago now. And this is great for our government audience in particular, as Google Maps is one of the things it's known for is having so many businesses. And in some of these public-facing maps that we're creating, we might like to turn those off or filter out just so we're showing relevant points of interest. So that's something that you can easily do coupled with this functionality, something that we really suggest you take advantage of now that it's part of the platform.
All right, and the next one I see is, what is the cost to use this feature? Is there an additional cost?
Great question. And the good news is no, there actually is no additional cost other than just the loading of the map itself, which is through the Maps JavaScript API. So everything you saw today was based on one API call just as no different than if we were putting together a plain map with none of these overlays on top. I will say that there is a more advanced function of this feature called region lookup. If, for example, you needed to grab the name of a town from a point and then relate that to a polygon on the map, that region lookup tool is still experimental right now, and pricing is to be announced. But in the meantime, you can effectively get started with all of these features at no additional cost, which is great news. Anything you wanted to add there, Dave, if you're on?
No, that sounded good.
Great.
All right, this next one says, you might have already answered this, and I apologize, but are these new
No
features
worries.
available now or being rolled out over time?
So everything you saw today is available now. Some of them may still be in a slightly beta mode, but they are completely available to the public as Google Maps users. It's our understanding that what you see today in terms of this polygon-based boundaries is the first step of what we hope is many toward additional functionality. So we're going to be keeping our eyes peeled for what might be coming next, including maybe bringing in your own polygons. But for now, everything that we looked at today is available and ready to use.
Says, we build bus routes on top of a Google Map background, but find that we cannot build traces on roads that are transit only. Is there any easy way to remove the restrictions on traces?
So it sounds like that's something that's relating to one of the other APIs in like the roads or routes functionality. It's a little bit outside of the scope of this webinar, but we'd love to get in touch with you maybe off the call to explore that a little bit further. It sounds like something that we might be able to look into.
Right. And can I use a spreadsheet or database to feed into this can I use a spreadsheet or database to feed into this to make the map?
Yes. So everything that you saw today was created just using, a basic Excel type of sheet where we had the zip codes in one column and the values in another. You, in theory, can get quite a bit fancier if you wanted to read an external data source, which would allow you to have a map that updates live in the background. So, the user comes to the map and it's automatically accessing the latest information. This is something that we'd be able to help you with, but at the very simplest terms, all you need to do when to put together one of these maps is have a list of supported geographies, like the towns or zip codes in one column, and in the other, a list of values, numerical values in this case, are supported.
One other comment on that question.
Sure.
It is up to the application to read in the spreadsheet or read from a database table and then present that data to the the Maps API to drive the data-driven styling. Google does not read the tabular data directly on its own from files, so the application has to take the responsibility for doing that.
Correct. So you could have the values that you're looking to display in the map directly in the code of the application, or you could have your application that you're writing out point to, let's say, like a CSV file or a JSON file, for those of you familiar with that, to grab the values.
And
in any case, it's quite straightforward to set up.
Yeah, one other comment, it's very interesting, is that if you build an application or have an application built using this type of technology for generating thematics, and you're pointing the application to a database table, every time that application comes up and presents a thematic, it's going to do a live refresh of the data. So you could be populating that data from other sources behind the scenes into that database table, and you're always going to have a live view. That would be especially relevant for tabular data that is changing quite a bit over time, and you're always getting a live view of thematics in the application.
Absolutely. So a key advantage there is, many times when you create a map in GIS software, you might create it once and publish it out, and then things change and you have to go and do that process again and again. In this example, we could create something where you set your classification up and have that live data read that Dave was referring to and never have to touch it again. And your users will always have access to the latest and greatest data.
All right, the next question says, where do we begin using the system? Or I'm sorry, it says, where do we go to begin using the system? Oh,
so great question. So if you're already a Google Maps platform user, you're going to log into your console, and they have some developer related information that can help you get started. You will also find there, as we looked at the very beginning of the presentation, the options to turn it on, as it is kind of an opt-in feature. And if you have a particular project in mind, always feel free to reach out to AppGeo and we can help guide you in the right direction. But Google has a lot of great info on their support page as well for getting started.
Kelsey, if you wouldn't mind, go to the next slide, and there's a contact information for Caresoft. So if you're not already working with Google Maps and you'd like to explore the whole world of the Google Maps platform further, I recommend you reach out to Carlos Fuentes, and then he will connect you with us, and we can have an exploratory call with you.
All right, and then we have another question. It says, can I customize the map shown underneath to my liking? For example, control what points appear on the map.
Yep, so we looked at that in a previous question a little bit, but again, you can have a great deal of customization of the base map shown. You could start with the classic Google map that everyone's familiar with and make slight tweaks. But I will mention, and this is something I put into action with the demos that you looked at today. When we're creating these overlay maps, it's often a good idea to apply some degree of simplification. So like the map we're looking at on the screen here is actually using like a more black and white base map underneath. And the reason for that is, traditionally we're used to seeing like parks as green and lakes and all these different things that have color to them. But when we're then adding a overlay on top that say green means something else, that can create confusion for your viewers. So we like to suggest taking advantage of those styling features to make a more simplified map, maybe a more monochrome map, and then using that as your canvas to lay these thematics on top of. So yeah, great question, and we really do encourage the customization throughout this process.
All right, thank you, Aaron. It seems like that's all we have time for today. I want to thank all of our participants, as well as Aaron and David, for being with us today. We hope our webinar has been helpful for you and your organization. If you have any further questions or would like to request more information, please feel free to contact Carlos at Caresoft. His contact information is displayed on your screen, so please don't hesitate to call or email him. Thank you and have a great day.